Hello, Assalamu alaikum. Welcome to lecture number 4 of ATmega 32. In today's lecture, we will study about data memory and assembly language of ATmega 32. Data memory is the most important memory in ATmega 32. It consists of 32 general purpose registers, 64 I/O registers, and SRAM. SRAM is the most important memory in data memory, and one of the most other important memory is general purpose registers. These are used to store data temporarily, and SRAM is used to store data permanently. It also consists of 64 I/O registers. I/O registers are known as input-output registers. These are 8-bit registers, and it has 64 I/O registers. Now coming towards 32 general purpose registers. Out of these 32 general purpose registers, as I told in the previous lecture, only 15 general purpose registers are usable by using LDS statement, and other 15 are reserved. The 15 which are usable are from 16 to 31, and other 15 which are reserved are from 0 to 15. There and the I/O registers, we will study about I/O registers when we will discuss about timers, ADCs, and etc. SRAM is the most important memory which we will discuss today in our lecture. Using LDS statement, which I have discussed in the last lecture, we can access only general purpose registers, and we can store only information in the general purpose registers by using LDS statement. But we cannot access SRAM by using LDI statement. SRAM is also known as EEPROM. Now what should we do if we want to store our data in SRAM permanently? We will study a new command for it, so please hold a second. LDS statement, which is used to access data memory SRAM, is LDS instruction. By using LDS instruction, we can access SRAM. LDS instruction is used to load data from SRAM into GPR to perform arithmetic or logic operations on that data. LDS instruction is the most important instruction. It stands as load direct from data space. LDS instruction loads GPR with data that is stored in SRAM. LDS, as I told before, load direct from data space, and in simple words we can say that load from SRAM. What additional information does the LDS instruction require? LDS instruction require address of memory from where data is read. We have to know where the data is stored in SRAM, or we have to know in which register we have to copy that data. Its syntax is LDS RD, K. RD represents the register in which we want to store the data, which is placed at K memory address. GPR register can be ranged from 0 to R31. One of the most important and major difference among LDS statement and LDI statement is that by using LDS statement you can access full GPR as memory, which is not possible by using LDS statement. By using LDS statement, you can access only register from R0 to by using LDS statement, you can only access registers from R16 to R31, but by using LDS statement, you can access full GPRS memory from R0 to R31. In this, K represents the memory address of $000 to $FFF. Dollar signs representing the hazard value of address. This command means that R20 will get the value which is placed at 0 cross 1 hazard decimal address of memory, means load R20 with an 8-bit data value from a memory address 0 cross 1. 0 cross 1 also represents R1, which is the first GPR register, or it is copying the R1 data into R20. LDS R5 0 cross 200 means it stores data from 0 cross 200 memory location into R5. LDS R0 means it stores data from 0 cross 300 memory location into R0. LDS R1 means it stores data from 0 cross 200 into R1. Add. Now add instruction means that it adds data of R0 and R1 and store that data back to R1. STS instruction. STS instruction means that it is used to store data from GPRS registers to memory, store direct to data space. Take the value from GPRS and store that value back to data space. What additional information does the STS instruction require? STS instruction requires register from where data is to be copied and address where data has to be written permanently. As we know that SRAM stores data permanently. STSK.RR. In this, the one major thing you have to understand that now memory address comes before the register from where data is to be copied and is to be written at that memory location. Similarly, registers from R0 to R31 and memory address from has a value 00 to has a value FFF. It stores R10 data to 0x1 memory locations, means simply R10 data to R1. It means that it stores R25 data to 0x230 memory location. LDS. Now LDS means that 0x300 memory location data will be written to R0. 0x200 to be written to R1. You can see the difference among STS. In STS, if we want to store data to SRAM, then memory address comes before. But if we want to load data from memory address, then memory address comes after GPRS registers. What does these four instructions do? It takes data from 0x300 to R0, then it takes data from 0x200 memory location to R1, then add both data and store that data back to R1, and then store that result to 0x221 memory location by using STS statement. Now LDI. LDI store 0x999 has the value of 99 to R20. 0x99 is not representing the address of memory location. It is representing the heads-up value which is to be stored in R20. Now R20 will be stored back to 0x200 memory address of SRAM. Now R20 will again store memory address 2x01 of SRAM. Similarly, now R20 again store to 202, again to 203. The basic difference among, you can see that LDS is doing that 0x220. It is not now the header value. It is now the memory address of SRAM, which is from where the data will be stored back to R30. Now it is again representing the address from where data will be stored back to R31. Now it will add both R30 and R31 and store data back to R31. STS statement. Now what STS statement do? As we know that after addition of R31 and R30, the data is stored back, means the result is stored back to R31. The addition result is being stored to the memory location of SRAM 0x221. How will you store value 0x99, 0x85, has the value 3F, has the value 3, has the value 12 into RAM equations from 212 to 216. Simply, you can do it by using LDS statement and STS statement. I would say please pause a moment and try to do this program by yourself. So please hold down and try to do it by yourself. Now I will share the solution. LDI, it is copying the header value of 0x99 to R16 and storing that value from R16 to that memory address by using STS, then 85 to R16, then R13, then R214, then 215, then finally to has the value of 260. Now coming to word instruction is used to access IO registers. As I told, IO registers is also a part of data memory. IO registers means input output registers. CPU loads GPR from IO register, means it takes value from input output devices and store that value into the GPRS temporarily stored register. In instruction stores content of register 16 0 cross 16 is representing the address of IO register from which the data is being stored in R20. Since the IO registers are part of the data memory, therefore registers are register 16 of IO memory is also memory address of 36 of memory. LDS is same like in statement. LDS can also access IO registers, but in statement has many advantages over LDS statement. What is the advantage of instruction? Number one, it can execute faster as compared to LDS because it requires just one machine cycle, while LDS requires 2 machine cycles to execute. In instruction is also just required 2 byte, while LDS instruction requires 4 byte in code memory. So in instruction is more efficient as compared to LDS instruction. But one of the major disadvantage of in statement is that in statement can only used for IO registers, means through in statement we can only access IO registers, not SRAM. Or one of the basic advantage of LDS statement is that by using LDS we can access any register. Out instruction is just the inverse of in instruction. Out instruction is used to send data from GPR registers to IO registers, means sending some data from GPRS registers of microcontroller at Mega 32 to some output to some device or to some output display. In this, out 0 cross 18, R20 means the data which is present at R20 must be sent to 0 cross 118. The hexadecimal value of 18 representing the address of IO registers or telling which IO register to be data has to be sent. Transfer data between IO port. Now it is a program for you guys and I hope you can do it. Write a program to get data from pin B and send it to the IO registers of port C continuously. First of all, we will get some data from pin B to R16 by using in command, and then we will send that data to port C by using out command. And as it is sent continuously, then we should use some type of loop that make it continuous. Jump again, making it continuous. It is a continuous, or we can say it is a forever loop. It will never end. For whenever we want to take some input from some IO registers, we always name it as pin B, pin C, pin A, or pin D. Or whenever we want to put some output on some port C, D, A, or B, we will use port C, port B, port D, port A. We will never use pin A, B, pin C, or pin D. It is the major mistake that many of you guys will do while programming it. Some guys may write port C or port B here, but it is not. Whenever you want to take an input from some port, you have to write it as pin B here. And whenever you want to send some data to the output device, you have to write port C like this. Move instruction is used to copy data among GPRS registers, means it can only copy data among GPRS. It cannot copy data among SRAM memory locations, something like that. Many of you guys will also use move command to copy it among SRAM memory locations, but it is not valid for that. It is only valid for GPR registers. It can move data from GPR registers 31, moving 31 to 32, 31 to 30, 29, 28, something like that. And move command sentence is like this. In this, R10 and R20 is the example. Which data is moving? In this, R20 data is moving to R10. Inc and DEC instruction. Inc instruction increments the content of RD by 1, and DEC instruction decrements the content of RD by 1. Simple. Inc instruction means increment and DEC instruction means decrement. Increment by 1, decrement by. Subcommand instruction is used to subtract the values contained between two GPRS registers like this. COM instruction stands for complement. It takes the complement of the value which is present inside the register like this. As in the example, before the RD was this, after taking its complement it becomes like this. The point where is 0, it turns to 1, where was 1 it turns to 0, where was 0 it turns to 1, where was 1 it turns to 0, and similarly here, where was 1 it turns to 0 and 0. Hence it was the end of lecture number 4. Subscribe for more, and you must also subscribe if you want to become master in AVR at Mega 32. because I'm going to be uploading more lectures related to AVR at Mega 32. Like if you are happy, comment if you have any question.